So my name is Bastien from Onera, the French Aerospace Lab in Lille, north France. And I will present one part of my work that I've done during my PhD students at Onera. So the title of my presentation is Influence of the non-Seghir terms and the crack velocity or KIC of an epoxy resin. So in aerotic field, composite material I use to reduce the weight of the structure. We can mention the Airbus 350 we have manufactured with at least 50% of composite materials. But this type of materials can be impacted and at different speed, which can lead to which can destroy the structure, as we can see here with the when we burn when they are a burst strike. Indeed, when the composite material is impacted, there are different fracture mechanisms. We can mention matrix crack, fiber crack, or delamination. Delamination is the decohesion of the interlaminar environment, which can lead to the destruction of the structure. When we speak about delamination, there are two types of fracture: adhesive fracture. The crack propagates at the interface between the matrix and the fiber, but there are also cohesive fracture, when the crack propagates only on the matrix, on the resin. So in my work, we have only focused on cohesive fracture. So the question is, during my PhD student, was how to evaluate the critical energy release rate, so G1C in mode 1 for high crack velocity, because we want to have high crack velocity when we have burst strike, for example. So there are two main approaches that I can mention. The first one is the macroscopic approach with global measurements, load, displacement, and it's allowed to determine the critical energy release rate, G1C. But in the literature on composite materials, there are important variations of the result between the different studies. The other approach that I can mention is a microscopic approach with local measurement near the crack tip, and it's based on the determination of the critical stress intensity factor, K1C. So in my PhD student, we have decided to use this second approach, this one. So I will develop the method that we used and the materials that we studied, and I will see then the crack propagation velocity effect, and I will conclude my presentation with some conclusion as possible. So the considered approach is based on the linear elastic fracture mechanics, and especially the Williams series. So the Williams series corresponds to the displacement field near the crack tip. It can be So it's written here when ING are wave coefficient and PNG are complex function. J equal 1 or 2 correspond to fracture mode, tension mode, mode 1, or shear mode 2. So the Seghir term, K1, can be extracted from this series, and K1 can be is proportional to the stress displacement, and the von Mises stresses can be represented here when K1 equal to 1 MPa square meter, for example, and we have this shape of the von Mises stress. But the literature shows that also there are non-Seghir terms we have been taken into account to see geometrical effects. IOTEL mentions that there are different crack paths according to the considered specimen. And if you look at the influence of the T stress value, you can see that if you change the value of the T stress value, you have a modification of the fast stress field. Kumar studies the B stress, the second non-Seghir term, and shows that an influence of the apparent fracture toughness and depend on the considered specimen. Now, if you look at the von Mises-Solsil, you can see that the modification of the B stress have an influence of the far stress field because it depends of the stress by this relation. So the question is how to determine these three terms. So we developed the method based on the digital image collection with UFreckle software. So we have an example of digital image collection here. With numerical parameter, mesh, spatial resolution, temporal resolution, spectral pattern, we need to be careful with this parameter. And the second step is the projection of this displacement field onto the Williams series. We have an example of the projection here. And we have to be careful with the projection zone, especially the radius, the minimum radius and the maximum radius. So during my PhD students, we studied the epoxy resin X-M21 used to manufacture laminated composites. It's a thermosetting resin with inclusion of thermoplastic nodules and with these elastic properties. We have an example of the resin with the black point correspond to the thermoplastic nodules. And the mesh elements that we use for the collage for the KIC has a size of 350 microns, which are more important than the size. We have a homogeneous scale. So to demonstrate the structural effect, we use different geometry, different specimens. The temporal double cantilever beam, TDC-based specimen. We have a crack propagation stability according to the literature. And we chose another specimen, a triangular specimen with different value of T and D. The consideration of structural effect on fracture behavior has been studied, and a paper has been written at the beginning of the year about this point. So I want to mention the result of KIC static and this and the different version of the paper. I will focus on only the crack propagation velocity effect. So we used hydraulic jacks with different loading rates to have different crack propagation velocity. We have a high-speed camera. We have the lighting. And we use the triangular specimen with a spectral pattern with paint, black and white paint, to use digital image collection. However, with these loading rates, we have only high-speed crack propagation up to 200 meters per second. We wanted to have crack propagation higher than this crack propagation speed, so we decided to change something. Because we could increase the loading rates, but we had inertial effect, and the crack path was not straight. We had a bifurcation of the cracks, so we decided to adding a circular notch adding a circular notch to replace. We replace the sharp crack by a circular notch with a diameter of 1 millimeter to have an adapted specimen to increase the crack propagation speed. So it's the result of the crack propagation of the fracture experiments, and we have stable crack propagation. Now, if we look at local analysis, we can see here the crack propagation velocity. We decrease with the crack propagation, which can be explained by the store energy at the crack tip, which decreased during the crack propagation. But we have crack propagation speed between 200 and 500 meters per second. It was as expected. So now we used all fracture specimens that I did during my PhD students to show the evolution of the critical stress factor with the crack velocity. So we can see we have an increase of the sparsity factor with the crack velocity. And now, if you look at the non-Seghir term, we can see the evolution of the T-stress with the normalized crack propagation, and we can see two trends. The first one is for sharp tip, and the second one is for sharp notch. Sorry, and the second one is for circular notch. For the B stress, we have a decrease of the B stress during the crack propagation, and the difference between the two, the same thing as 40, the difference between the results can be explained by the type of the notch, sharp or circular notch. The conclusion is that we made that loading speed control testing, we have a stable crack propagation. Stable because the loading controls the fracture experiments, and for the other type of fracture experiments, the test is not controlled anymore by the loading speed, so we call them unstable. So to conclude, we have developed a microscopic analysis methodology using 4-field measurements to determine the critical strength factor in mode 1 and the non-Seghir term T and B. We have modified the specimen to perform fracture experiments in mode 1 with high crack velocities, and we saw, as explained, an increase of the critical strength factor with the crack velocities. I can mention that this trend has been seen in the literature for other type of material like PMMA, for example. And so the prospect are the following: the development of the new experimental setup with other type of specimen to have a different range of T and B value, and to create a K1C model based on test data, as I did in KIC static on the paper that I showed. So thank you for attention. I know something was very fast, so if you have any question, I'm happy to answer them. Thank you.